Houston Nation University and Korea Electronic Technology Institute.
Good morning, ladies and gentlemen. It's a pleasure to be here today. My name is Phanit-Sok and I come from Cambodia. Currently, I'm a graduate student in Mechatronic Engineering at Cheongsam National University, South Korea. And now I will be presenting on the topic, the chroma clamping circuit to reduce the source voltage in the DC solid-state circuit breaker. Let's get started. So, number one, I will talk about the background in the previous research of positive DC solid-state circuit breaker. So, the DC solid-state circuit breaker has been researched to identity of the fault current, protecting the load and system equipment from damage due to excessive fault current. So you can see, like in the circuit, they divide into DC gate and breaker. In the breaker path, you might see a movie device. A movie stands for metal oxide resistor, and it's as the energy dissipation device when the fault current occurs. Next, the previous research proposed that DC solid-state circuit breaker can detect the fault current and energy dissipation in 10 microseconds, but facing with the source voltage issue. Second, the problem that leads to the source voltage. Recently, so many people also research this problem too. So, the source voltage have a value proportional to the strength inductance and the characteristic of the MOV itself. First one, when the MOV brand as the energy dissipation device, the fault current decreases from the maximum blocking current to zero. So, the derivative result of MOV current gonna be result in negative. So you can calculate like voltage between the strength inductance result in positive. And second, is the current rest to the source current region of the MOV. You can see this part in the graph. The voltage of the MOV on that time very high and combined with the strength inductance. So the voltage between of the semiconductor switch increase very quickly and easily damages. So the source voltage suppression message was positive. So now I will talk about the previous research proposed for the source voltage suppression message. For the first one, they still keep the breaker path, but they add resistor and capacitor snowball circuit. So when the main switch was turned off, Icasi snowball circuit act as the temporary energy assumption. Second one, they try to increase gate resistance or capacity, add capacitor between the gate and source. So the main idea of this proposal, they try to change off the total gate charge so they can delay a little bit about the turn off time. The last one, they optimize voltage by dividing over voltage protection and energy assumption into separate resistor. For lower DC rated voltage for over voltage protection and a higher DC rated voltage for energy assumption. Here, this is my circuit that I will propose in my paper. Also, the red one you can see is the chroma clamping circuit. So, in my post, I will optimize voltage divide over voltage protection and energy assumption into 3 separate resistors. A double lower DC rated for over voltage protection and higher DC voltage for energy assumption. So, when the normal operation, the voltage and current of the redstone L1 and the set of the gate of tristor at low value, so the tristor will be turned off. So when the fault current occurs, the voltage and current of the redstone L1 have value enough to turn the tristor on. Now I will talk about how to simulate and create a moving model. So a general equation of the resistor and relationship between voltage and current you can see followed by this equation, but somehow we have some problem. So the library of PSPI have limit about the resistor to simulate by changing parameter like B1, B2, B3, and B4. So for example, you have a new model of some movie, you cannot simulate it. So now I will show you how to find it. So I introduce about the curve fit function. The curve fit function is the tool in the SciPy library of the Python program, like to find the best parameter for given function that fit your data set. So here the flow process of the curve complete function. So for example, you have 60 the data point exactly of the voltage and current. So you want to find like all parameter you. So the complete function can show this problem. Here my graph that I tracking around like 60 data point. After that, the red curve is my result, followed by all the parameter about the graph, and also include the error too. Now I will explain about operation principle of chroma clumping method. So I will split into 5 separate parts. For A, doing normal operation. So the current element will be flow from the voltage source to the load as usual. B, when the fault current occurs, so the current of the voltage divider branch will be increased on the same time as element. So after that, when the element around 80% of the maximum blocking current, so the resistance L1 voltage and current will be turned transistor on. So C, the fault current rests to the threshold value, so the semiconductor switch was turned off. You can see all the total fault current will be flow into the original MOV branch, transistor branch, and voltage divider branch. And D, so the original MOV branch will have a current oscillate and disappear very short time after that. So only a transistor branch and voltage divider branch still like continually decrease itself until the value is among zero. The final is the breaker path completely doesn't have a fault current anymore. So now we talk about selecting method of the MOV1 and MOV2. So table 1 is simulation parameter, like also like detail about description, and one by one respectively. In the red box is that I mentioned before, like original MOV as higher DC rated voltage, also V1, V2, V3. I already defined in the previous like a complete function for you. So when you choose MOV1 and MOV2, you must like followed by equation 2. After that, maybe you can like calculate your centimeter by equation 1. But after that, for example, like I just according to the MOV title of piece by library for title 1 and title 2. Somehow if I choose like a double of title 1 connect with transistor like this, and title 2 connect like transistor like this, somehow like I get the result centimeter around like 23.2%. The same. You might be wonderful. Which one is the best solution for me? So we can predict it. So the voltage of MOV is proportional to the current based on the maximum clamping voltage graph of ear title. So I can assume that adding title 2 instead of title 1 into my proportional circuit is the best option for reduce the source voltage. So here my simulation waveform result of title 1 compared with title 2, and also like the previous DC series circuit breaker. You can see the title 1 is around like 2.5 kilovolt reduced, but title 2 is a little bit better than, so around 2.36 kilovolt. If we compare with the previous DC series circuit breaker, right, around 3.35 kilovolt. And the second graph, I will talk about H-like simulation current waveform at the moment of circuit breaker operate. So you can see is the blue current is represented by like original MOV brand. You can see like the current oscillate and disappear very short time. So after that, the voltage will be depend on the transistor brand. You can see is the yellow current. Final, I will talk about the simulation result and discussion. So in any specific condition and selecting message of the MOV1 and MOV2, is the voltage rated DC total of MOV1 and MOV2 is give us like the same centimeter value refer to like equation 1 and equation 2. So we must choose the title as MOV1 and MOV2 with the higher current in the lower maximum clamping voltage. So table 3, I summarize all the source voltage and centimeter depend on the MOV combination. MOV1 and MOV2, you can choose the same model to connect together or different model to connect together, but you must follow that condition depend on equation 1 and equation 2. So, and here the previous DC series circuit breaker voltage piece. So finally, I wrote my conclusion like the system reduce a small value of the source voltage. reduce a small value of the source voltage, so you can get very high centimeter of that movie itself. So, but somehow, if you want to reduce very large value of the source voltage, you will get very low like centimeter on the movie of movie 1 and movie 2. So, thank you so much for your attention.
Any question? Is it possible to use three OV? Now you use two, right?
Yes, it's
to
possible.
further improve the performance of the circuit.
Yes, it's possible to use 3 wires on the same time, but somehow we must we make sure that include according to the equation too, because if you choose that model too low too much, when you connect it in the circuit, so somehow the voltage source is very high, it can be done with the MOV itself. So that's why I mentioned when you choose, it means they will have own DC relative voltage on it model. So for example, I try to use in a discrete that voltage. You can see the voltage discrete too, but somehow the centimeter on that model is very dangerous. It's the make on the time too. Yes.
Thank you. Yeah, please sign here.